Okay, what we're going to do today is we're going to look at the beginning of our textbook, and the first topic is 1.2 from chapter 1, and it deals with number sets. So we often wonder, what is a set? Well, we speak of a set of dishes, a set of silverware, a set of stamps, but in math we talk about a set of numbers, number sets. And this sets up the whole area of how we're going to use these numbers and how they interrelate as we move on to future topics. And you sort of maybe think of the cavemen, or and they wanted to develop a number system, and they said, well, here is one thing, and then here two things, and three things, and so on. So we speak of the first set of numbers, and again, I don't know how it came about, but I'm sure other authors have written about it. The natural numbers, and sometimes they're called counting numbers. So how do we count? Well, 1, 2, 3, and then continue the pattern. Now these little 3 dots here are called an ellipsis, and what they indicate is the same pattern continues. You set up the pattern, and then it continues, and you can use the 3 dots. The other thing is, when we're writing a set, we put braces around it, and then the items in the set are referred to as elements or members of the set. So this is the set of natural numbers. Now often we like to illustrate that, and we would illustrate the set of natural numbers on a number line. And to illustrate natural numbers, we would put dots on 1, 2, 3, 4, 5, and then to indicate that it's moving in that direction, we would just emphasize the arrow indicating, in a sense, the ellipsis going on in that direction. So this is the set, the graph of the set of natural numbers. The next group are whole numbers, and as you look at them, it looks very similar. In fact, the only thing added is the number 0. When we plot it on the line here, this is now the graph of the number set for whole numbers. Now, as we look at the number line, there are other numbers on the other side. And we say that there is an opposite of number 1. That opposite is a negative 1 over here. And if we were to graph it, of course, we'd start going like that. So 1 has an opposite, a negative 1, so that when they are added together, it's going to equal 0. So we call 1 and negative 1 additive inverses. The inverse of a negative 1 is a positive 1. The inverse of a positive 1 is a negative 1. So this gets rise to our next set of numbers, which are the integers. And we write the set by using a dot, 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 indicating it's coming from, what's over here, by the way, is negative infinity, and what's over here is positive infinity. So this is coming from negative infinity. Here's our pattern. and then continuing on to positive infinity. So far we have 3 sets of numbers, and I would advise you, to write them down, practice them, and there will be some examples to work with. And then you might say, well, are there other numbers in between? For instance, and let me change colors here. Let's use green. Right here, is there a number? Yes, and we know that number is 1/2. And over here, there's another 3/2, and so on and so forth. There's also, like right there, is 1/3. And you might say, oh, those are the fractions. And that is another part of our number line. And these fractions that come between integers, we usually refer to the fractions as rational numbers. So these are the numbers on the number line that are not, in a sense, integers. They are between integers. But keep in mind that rational numbers also include integers. For instance, we could write 1 as 2/2. It's in a fraction form, but it's 1. So this would be a whole number, as well as an integer, as well as a natural number, and a rational number. Now, are there other numbers there too? Well, yes. If you went over here on the other side of 1, right about there, we have the square root of 2. And over 2, we have here the square root of 5. And generally speaking, if we have a perfect square, like the square root of 4, the square root of 4 is 2. So even though it's under the radical sign, it is an integer, a whole number, a natural number, and a rational number. But the square root of 2 and the square root of 5 are what we call irrational numbers. And why is that? And the one I often use is if you take the decimal, or the fraction 1/2, convert it to a decimal, it becomes 0.5. Now 0.5 is the decimal form of 1/2, and it terminates right there. So we consider that a rational number. If we have the number 1/3 in decimal form, it starts to go 3, and the 3's repeat. And we put a little repeating bar over the 3, indicating that it repeats. So if a decimal, or if a fraction in decimal form terminates like this, or repeats like this, we say it is rational. But if we put in there the square root of 2 and go to its decimal form, and it's like 1.414, and it continues, not in a particular pattern, but doesn't terminate or repeat, we say that this type of number is an irrational number. Another famous irrational number is pi, which is about 3.14. But that continues too. It doesn't terminate, and there's no repeating pattern. So we say those numbers are irrational. Now, but keep in mind, rational and irrational numbers are on the number line. So all of these, natural numbers, whole numbers, integers, rational numbers, irrational numbers, make up a big set of numbers. All of the numbers on the number line, these are real numbers. And we often use the symbol R for real numbers. Now what we're going to do is do some examples from our booklet. So we've put up some examples, again, from additional exercises in our little booklet. And these are available on Tegrity as well. So here it says x is such that x is an odd whole number less than 16. So we want to write that set. So we look over here at whole numbers that are going to be less than 16. So we would put our bracket and whole numbers and an odd whole number less than 16. So the key here is odd. So what number do we start with? 0? No. 1. And we use commas. 1, 3, 5, 7, 9, 11, 13, 15. And there's our, in set notation, that's how we write it. Okay, the next one, x is an integer that's greater than 20. So we go to our integers, put our brace. Now, since it's greater than 20, is 20 included in the set? No. So we start with 21, 22, 23. Now we've set up a pattern. So we can use our ellipsis, and that's how we would write it. All right, x is a natural number less than 9. So we go to our natural numbers, and we would start with 1, 2, 3, 4, 5, 6, 7, 8. Now, you might say, should I put 9 there? Well, it says less than 9. So 9 is not a member of the set. So in this next part, what we're looking at is a series of numbers that we want to list in the various categories. So of these numbers, which are natural numbers? Take a moment, and it would be 6. All right, rational numbers. Well, it would be 6, 0, 3/4, 3/7, and a negative 285. These are all rational numbers. Integers. Well, that would be 6. 0 is an integer. And a negative 285. And irrational numbers, we only have the square root of 5. Again, there are many more examples. If you go to Tegrity, we do all of these. And this is our short review.